Hello, this video discusses potential biases in real-world evidence. The objective in real-world evidence may be to assess the association between an exposure, such as treatment, with an endpoint, which may be an event of interest such as death or cure or success in management. What is bias? It's an error that occurs at some stage of the study and tends to produce results that are systematically different from the true effects. We wish to obtain an estimate as close as possible to reality, which is not known, by limiting the bias. To illustrate this, we can represent a target. If the measurements made are systematically off, i.e. all far from reality, the estimate is biased. On the contrary, if the measurements are around the real effect, the estimate is unbiased. Be careful not to confuse the bias with the variability of the measurements, also called random error, which results in a loss of precision represented here by the dispersion of the measurements on the target. Let's start with the selection bias. For example, we want to estimate the prevalence of obesity in France. Our population of interest is therefore all persons in France with a BMI greater than 30. If we assume that overweight is more frequent in rural areas than in urban areas, and if we decided to set up a SNDS study using only people affiliated to the General Health Insurance Scheme, then there may be a selection bias. Indeed, the prevalence of obesity may be underrepresented in the sample due to a systematic selection error, exclusion of persons affiliated to the agricultural schemes, mutual insurance companies. Selection bias is therefore a distortion of the estimate of the event studied in the study sample, from which it will be very difficult to extrapolate the result to the whole population. Let's continue with measurement bias, which is also called information bias. Let's imagine in the concept of a new treatment for weight loss that weight is measured at the time of treatment. Treatment A is given on an empty stomach in the morning and treatment B is given after lunch. The result will be biased because the method used to measure the study endpoint, but also the exposure or covariates, differ systematically between the groups. To avoid these errors, the endpoint, exposure and covariates should be clearly and precisely defined, and subjective proxies should be avoided whenever possible. In our example, if participants all weigh themselves in the morning on an empty stomach, this measure should be preferred. It should be noted that measurement and selection bias are not recoverable in the statistical analysis. They must be well identified during the design of the study. Let us now mention a bias that can be classified in the two biases mentioned above. This is the immortal time bias. For example, we are interested in hormone replacement therapy in postmenopausal women in the occurrence of a cardiovascular event. An immortal time period can be observed when there is a delay between the start of follow-up and the start of treatment. How can this period be managed? A first way of doing this is as follows. All women who have taken hormone replacement therapy are included in the treatment group at the beginning of the follow-up, even though they had not yet started the treatment. Here we are in the presence of a measurement bias. A second way is to exclude this period of immortal time completely from the analysis and to consider the beginning of follow-up at the same time as the beginning of treatment. This is a selection bias. In both cases, there is an error in the estimation. The woman should have been considered in the untreated group during this immortal time period and then in the treated group. The last type of bias, confounding bias, is discussed in the next video. See you soon and thank you for your attention.